complex fractions. Guys, what a complex fraction is, it just means fractions within fractions. So our goal is, we know how to divide fractions, but to do our little trick, dividing fractions is easy as pi, flip the second and multiply. To do that trick, everyone listen. So to flip this and have c over b, we would have to have only one fraction on top, not separated by a plus sign. So do you see how here we have two fractions on top? We cannot do flip the second and multiply in that case. So we need one fraction divided by one fraction. Now look at the denominator here. This is one fraction. Two terms versus one term. One term is good, two terms is not. So we just need to simplify it in sections basically. So you'd say, okay, the top it has two terms. I need to simplify the top. So I'm going to make myself a little note. Here we go. So simplify the top. How do we add fractions? Get a common denominator, right? So how do we do that? We factor the denominators. Done. Get a common denominator. So I'm going to multiply by x over x. 3 over 3. You all agree? Then the next step is to multiply out the numerator with adding and subtracting. We have to keep the steps separated in our head. So 1 times x is x, plus sign. Then we have 3 times 1 is 3. And then that's all over the common denominator of 3x. Are we all good with that? So I've already done that. So now I'm not going to write top then, because I just did it up there. Okay, so on top we have this. X plus 3. On bottom we have x plus 3 over 3x. On bottom we have x plus 3 over 2. We're not going to worry about restricting complex fractions. We're just going to simplify, okay? I will tell you on the test if I want you to restrict, but you're not going to be asked to restrict complex fractions. Even though we could. What would we restrict? Here, here, and here, right, everyone? It's not like it's any harder, actually. Okay, so dividing fractions is easy as pi. We flip the second and multiply. Now we can do that. So 2 over x plus 3. When multiplying fractions, don't we factor all the parts? That's our first step, right? Multiplying fractions, factor all the parts. Then what do? Multiply straight across, but don't actually multiply, right? So on top, we have a 2. We have an x plus 3. On bottom, we have a 3x. We have an x plus 3. Then we'll divide out exact factors. Isn't that it? So our answer would have been 2 over 3x. So really not that hard, it's just two problems within one. Okay, so another one. So you'd say, okay, it says simplify. Now you'd say, oh, I can't flip the second because there's two parts here, so I need to make it one fraction. So to do that, I would get a common denominator. So wouldn't I multiply by z over z? 4 over 4? And we multiply out our numerator. Z times z is z squared, isn't it? Then we have a minus sign. Then we have a 16. Then on bottom, I have a 4z. That's just this. Then we have divided by z plus 4 over 16. Okay, dividing fractions is easy as pi. Flip the second and multiply. So we would times by 16 is now on top. Z plus 4 is now on bottom. When we multiply fractions, how do we do it? What are the steps? We have to know these steps like the back of our hand. We start doing things that are not the correct steps and we will miss the whole test. How do we multiply fractions? What's our first step? Factor all the pieces, people. Did we practice our homework over the weekend? Factor all the pieces. So let's factor this piece right here. What multiplies to be negative 16 and adds up to be 0. 4 times negative 4. I can quick factor. So that part factors to be x plus 4, x minus 4. I'm using x's all of a sudden. That's fine. Okay. Then on bottom, I have a 4x. That's all factored. Then we have a times sign. We have a 16. We have over x plus 4. Okay. Now don't we multiply straight across, but don't actually multiply. So is anyone mad that I'm just going to go like this to save time? Okay, let's divide out exact factors, because these are all multiplication signs even though they're not squished together. So we have an x plus 4, an x plus 4. A 16 and a 4. Can I divide those out? Times sign? Times sign? Yes, we can, right? There's not addition signs. If there was an addition sign, it'd be no. So 16 and 4. That becomes a 1. This becomes a 4. So what was left on top? 4 and x minus 4. Then on bottom, all that was left was a x. Okay, so let's do the same thing. So I'm going to give you 2 seconds to write this one down for yourself. Don't worry, I'm just separating out my... So this is the top, obviously. So I'm I'm going to have the word top right here, and I'm going to just simplify and put my answer for that right here. So let's just focus on top, everyone. You'd say we have two fractions that are separated by a subtraction sign. Now remember, I personally, to not make errors, go to the top and say if it's subtraction, I like to make it a plus sign and then distribute my negative to the top. Does everyone agree? Now when adding and subtracting fractions, the first step is to factor the denominator only. So let's factor, I'm just looking at the top here. That's good. So we have this factor. Let's factor this. Didn't we just factor that 2 seconds ago? That becomes what? X plus 4, x minus 4. Okay, so now you say I need a common denominator. This one has an x plus 4, so does this one. This one has an x minus 4, this one does not. So I need to multiply by x minus 4. The next step when adding or subtracting fractions is to multiply out the numerator. So I'm showing my work right here. 2x times x is 2x squared. 2x times negative 4 is negative 8x. And we're just doing the numerator, remember? Then we have a plus sign. Now we have minus x. And then we have a plus 7. Awesome. Combine the numerator. So we have 2x squared, no other x squared. Minus 8x minus 1x is minus 9x's, isn't it? Then we have a plus 7. That's the numerator, and that's all over the common denominator of x plus 4, x minus 4. Now I'm going to move on to the denominator, because I have one fraction right there. Let's split up our work here. So our denominator. So isn't this x over 1? So write that. You'd say, okay, when adding and subtracting fractions, I need to factor my denominators. Check. I need to get a least common denominator. This one has an x plus 4. This one does not. So this one needs an x plus 4, doesn't it? Then I personally, with subtraction, like to make it a plus sign and then distribute my negative through. Then you'd say, what's my next step when adding and subtracting? Multiply out the numerator. X times x is x squared. X times positive 4 is plus 4x's. Then we have a plus sign. This is just the numerator. Then we have a negative x squared. Then we have a minus 4, it looks like. So then combine like terms in the numerator. X squared minus x squared is gone. So we have it on top, 4x minus 4, and that's all over the common denominator of x plus 4. This is in the numerator, this is in the denominator. Is everybody good? So now you'd say, great, I have one fraction. So we're really looking at this. This fraction divided by 4x minus 4 over x plus 4. So what do? Dividing fractions is easy as pie. Flip the second fraction and multiply. So we have an x plus 4 on top now. And on bottom we have 4x minus 4. Then you would have to remember the steps in your head. How do I multiply rational expressions? Factor all the pieces and then multiply straight across, but don't actually multiply. So now you'd say, okay, I gotta factor all the pieces. So I'm gonna factor this piece right here. So it multiplies to be a times c, multiplies to be 14, and adds up to be, I need some room to write, it looks like. Okay, what multiplies to be 14 and adds up to be negative 9? Negative 7 and negative 2. Now we have the long factor, so we have a 2x squared drop. And we have a plus 7, and we break our middle term down as those two factors. So minus 2x minus 7x. Factoring by grouping. Pulling out a 2x. Left is x minus 1. Pulling out a negative 7. Left is x minus 1. Hopefully factoring at this point for us is this quick, so that I'm not confusing you when we factor that quick. We know how to factor a quadratic. right here to factor to be x minus 1, 2x minus 7. That's all over the factored x plus 4, x minus 4. Then on top, x plus, so times x plus 4. Then on bottom, it looks like we have a pull out of 4, left is x minus 1. And you'd say, when multiplying fractions, I multiply straight across, but I don't actually multiply. So I'm just going to extend my line to save time. These are time signs that I'll understand. And then I could put 4 in front if I wanted and scribble it out, and then remember that's a time sign. So we can divide across time signs. Aren't there all time signs here? So we have x plus 4 and x plus 4 divide out. X minus 1 and x minus 1 divide out. So then left on top is 2x minus 7. On bottom we have a 4 and a x minus 4. All that pain and suffering for such a small answer, but it was good. It was fun. Yes. Yeah, because multiplication can be reordered in any order. Because 2 times 3 is no different than 3 times 2. Does that make sense? Yeah. So if it was addition, we couldn't just magically, I mean, if it was addition, I guess we can too, kind of. But not if it was multiplied. But yeah, multiplication, yes, we can reorder. Great question. Can I divide that 2 and 4 out? No, that would be dividing across a subtraction sign. Don't start doing weird things. Okay. You guys good with this? It's not like it's anything new. It's just it's a big problem. A lot of potential for error. You have to keep the steps separated in your head. Okay, I don't think. Do you want to do another one? Not do another one. You think you can do them by yourself? So what will we do here? Factor the denominator. Factor the denominator. Get a least common denominator. Distribute the numerator. Combine the numerator over the denominator. Right here. What would I write? 4 over 1. So I multiply by x plus 2. X plus 2, I would distribute out the numerator, right? Combine the numerator over the denominator, flip a second, multiply, factor all the pieces, restrict, divide, if I ask you to restrict, but I'm not going to. Okay, awesome! I believe you then. So go take a second before we learn another method. We're going to learn another method to do these. It's actually a little bit quicker, but it's sometimes easier to do this way that I just showed you. So, go practice something like this, of this caliber. Ready, go. This always works. This method always works. Bring it down and explain. Okay, what I want you to notice is we have x to the negative 1 plus sign y to the negative 1 divided by x to the negative 3 plus y to the negative 3 versus x to the negative 1 times y to the negative 1. That's a time sign right there. And then we have x to the negative 3, y to the negative 3. That's a time sign. These are very different problems, and algebraically simplifying them are completely different. So we do have to realize something. So we all know when we have negative exponents, we flip them over a fraction. Now we have to be really careful though. When we have addition signs, we can't flip it quite like the way we would do it with multiplication. So something like this, because it's multiplication, don't we know that we can just take the base and flip it down? That's how it works, right? That fixes it. Take the base, flip it down. So we would be taking these bases and put them upstairs, and that would make them positive. So we would have x cubed, y cubed on top, and then divided by x to the 1, y to the 1 on bottom. This does not work the same way. You cannot do that because it has addition signs. We can't take x down here. Because then what about the addition sign? You're just kind of ignoring it. Like it's not the same. So what we have to do is we do have to fix the negative exponent, but you have to flip it over just itself. Meaning, this is 1 over x plus sign. Flip over itself. 1 over y. You guys see how that fixes it? Then we have a divide. And then right here we would flip it over itself. So that would be 1 over x cubed. Then we have a plus sign. And then we would have what? 1 over y cubed. Now you'd say, okay, I have a complex fraction because I have fractions within fractions. So our first step is to say, let's focus on the top here. We need to get it to be one term. So we need a common denominator. So we would multiply by y over y. We'd multiply by x over x, wouldn't we? So on top, we would now multiply out our numerator. Wouldn't we have this? Y times 1 is y, plus x times 1 is x, right? All over the common denominator of x, y. That's just the numerator. It is, yeah. Yeah. So what would my common denominator be down here? X cubed, y cubed. So this one needs a y cubed over y cubed. This one needs an x cubed over x cubed. So in the denominator, we multiply out the numerator now. So y cubed times 1 is y cubed. Plus sign. X cubed times 1 is x cubed. Then that's all over x cubed y cubed. And now we have one fraction divided by one fraction. So then we'd say, okay, now we can do dividing fractions as easy as pi, flip a second and multiply. Is everybody good up to here though? So it's just the same steps. So let's flip the second. So we times by, on top we have an x cubed, y cubed. Then on bottom we would have an y cubed plus x cubed. Then you'd say when multiplying fractions, I factor all the pieces actually. That's our first step. When multiplying fractions, we factor all the pieces. So you'd say, well, that's factored, y plus x. On bottom, xy is good. Then we have times x cubed, y cubed. Well, there's nothing more we can do with that. It's just multiplication. But now careful, right here, isn't this the sum of two perfect cubes? Yeah, so we can factor that. That's what we learned in our last unit that we just tested on. Cube root the front thing, we get y. Cube root the back thing, we get x. So you have a y and an x. Then you do the front times the front, y squared. Then the front times the back, yx. And the back times the back is x squared. And you say this sign's plus, so the original sign would be plus. The next sign over is subtraction. The next sign over is always plus. Then remember, within two perfect cubes, the quadratic part will never factor more. So we are done. And you'd say when multiplying straight across, I multiply straight across, but don't actually multiply it. So now on top, I have x cubed, y cubed. I'm multiplying straight across. I put those in front, it's just considered prettier. Then we have a y plus x. Then on bottom, I have an xy. Then I have an y plus x. Then I have a parentheses y squared minus yx plus x squared. Now can I divide out exact factors? Multiplication, multiplication. We can divide across multiplication. So x cubed and x divides out to become x squared on top, doesn't it? Y cubed and y divides out to become y squared on top. Then these divide out, and that's it. So on top was an x squared and a y squared. On bottom, all that's left was the y squared minus yx plus x squared. And we're done. Okay, just looking at one more that's similar to that, so we can know how to flip it correctly. Would it be appropriate to take this down here? Down here. No, because of the addition sign. You have to flip it over itself. Also, don't be the person that flips 3. 3 stays right where it's at, on top. That doesn't have a negative exponent. So we would have this, 3 over a, plus sign. Wouldn't we have 1 over b? Then we have divided by, then right here we would have 9 stays on top, 9 over a squared, minus sign, 1 over b squared. And then we would just say, okay, now I have I have a complex fraction here. So I'd get a common denominator. Can I fly through this next part like a maniac fast? Okay, here we go. So maybe b squared, a squared, true? So on bottom I have 9b squared, I have minus a squared, and that's all over a squared, b squared. That's the denominator. On top, I'd say times by b over b, times by a over a. So on top I have 3b plus a, if you're looking at top, all over ab, and then we have divided by 9b squared minus a squared, all over a squared, b squared. Dividing fractions is easy as pi. Flip the second fraction and multiply. So now I'm going to times by, on top is an a squared, b squared, true? And then on bottom would have been 9b squared minus a squared. And then I'd say, all right, now in multiplying fractions, I need to factor all the pieces. 3b plus a doesn't factor. So, right here, 3b plus a doesn't factor. 3b plus a is done. On bottom, ab is good. We have a times sign. That doesn't factor, it's just a times sign, so it's just a squared, b squared. Does everybody see? On bottom here, you said two perfect squares, don't I? So remember, two perfect squares don't work like two perfect cubes, but we start out similar. The square root of that is 3b, true? Square root of that is a. Now remember, it doesn't do front with the front, front with the back. That's a cubic. This is a quadratic. Middle terms canceled out. So what will the factors be? 3b and a, 3b and a. What will the signs be? Good, plus and minus. Now we factored it. So now we multiply straight across. I like to put the a squared b squared in front. It's just prettier. Times 3b plus a. On bottom, I have an ab. I have 3b minus a, 3b plus a. We're not asking you to restrict, so now all you have to do is divide out exact factors. So this would divide out to become an a on top. This would divide out to become a b on top. These would divide out. So left on top was an a and a b. Left on bottom was 3b minus a. We can do hard things in this class. I know we can. Okay, I know we can. I know it's hard though. I'm not saying this is easy. Now remember, the math lab, you can come in every day this week to the math lab. There are people at 1010 at UVU. They really do have to go to the math lab every day. So, study guys. Come in Monday through Thursday into Robert's room after school and get help. Today I'll be here after school though, in here. Okay, that's the end of the lesson. I know you guys can do hard things. You're awesome.